Let's give it to your solenoid students. A solenoid of length 25 centimeters. This is the first question, students. Solenoid of length 25 centimeter has an inner radius of 1 centimeter and is made up of 250 turns. The current flowing through it is 3 ampere. Find the magnitude of magnetic field inside the solenoid. Magnetic field inside the solenoid. And magnetic field at one end of solenoid. Okay, that's the first question, students. The next question is, one more question, students, I'm giving it to you. A bar magnet of moment of inertia. Students, a bar magnet of moment of inertia, 500 grams centimeter square. Makes 10 oscillations per minute. In a horizontal plane. What is the magnetic moment of the horizontal component of the Earth's magnetic field? What is the magnetic moment? You have to find out the magnetic moment of the bar magnet. If Earth's horizontal magnetic field, BH, is given to you, 0.36 G. Friends, are the two questions clear with you? The first question speaks about, for a solenoid, length is given to 25 centimeter, inner radius is 1 centimeter, 250 turns, current is 3 amperes. Find out the magnetic field intensity inside the solenoid and at one end of the solenoid. Second question, for a bar magnet, the moment of inertia is given to you 500 grams centimeter square. It makes 10 oscillations per minute. I want you to find out the magnetic moment of the bar magnet if the Earth's external horizontal magnetic field is 0.36 capital G. Students, are the questions clear to all of you all? Both these questions, first tell me that.
Yes.
Okay. Is anyone? Since you'll get these two answers. Yes, anybody? Aman, tell me what's the formula? Jagannath, can you tell me what's the formula?
Mu naught Ni.
Of course. So are you getting it or you're not?
I'm doing the 1 and 1.
This is mu naught Ni and N is number of turns per unit length. Number of turns is given to you as this. Length you convert from centimeter to meter. And mu naught is 4 pi. 4 pi into 10 raised to minus 7. This will be number of turns is 250. Upon length is 25 into 10 raised to minus 2 we consider. Into current is given to us 3 ampere. 4 3s are 12, 12 3s are 36, and this will get cancelled. Your answer will be around 36 ke aaspas hi. And if I say at 1 end, then what exactly formula will be mu naught Ni divided by 2. Students, is this clear?
Yes, sir.
Okay, what about this part now?
Sir,
Yes.
so we didn't have to use any radius calculations.
What?
We are given the inner radius, sir.
My dear, that's for a solenoid, we have to go for length. You're not
Yes.
the diameter is very small in comparison to the length. Since this is very small, so we neglect this length part of a small r. We go for 25. What's the definition of a solenoid? I stressed it very, very clearly in the last lecture. A solenoid is a simple insulated wire, insulated copper wire wound in form of a single helix such that its diameter is very small. Diameter is very small in comparison to its length. That is when the formula we go for number of turns per unit length, L, and not the circumference of each coil. No, we are not taking that at all. So this radius is not of use at all. For toroid, we go for circumference. Is that clear?
Yes, sir. So that was only for confusion.
Yes.
Okay.
Can I get the answer for this one? Bar magnet? Anybody? Students, anybody can tell me what's the formula for moment of inertia for a bar magnet? Rotational dynamics. Aman, answer Aman. Moment of inertia for a bar magnet. Or if I give you a rectangular rigid lamina of length L, breadth B, thickness negligible. What is the moment of inertia about an axis perpendicular to its plane and passing through center of mass? Aman, are you there? Since the formula for moment of inertia for a bar magnet is ml square plus breadth square divided by 12. And this is actually the formula for a rectangular lamina only, students. वही अगर rectangular lamina को मैंने square lamina कर दिया, each side is same, तो b square की जगह पे l square आ जाएगा. तो formula क्या होगा? ml square by 6. Students, is this clear to all of you all? Moment of inertia is the product of mass into square of the distance of its constituent particles from the axis of rotation. So it's algebraic sum of mi ri square. If the mass is in discrete manner, continuous manner, it's dm into r square, integration of dm into r square. Students, is the audio and video fine with you all? Are you able to hear me clearly? Okay. Okay, fine. Now listen carefully, students. They're asking you for this. Students, we are simply going for time period. Time period for a bar magnet is 2 pi under root I upon MB. And students, everybody has known this in oscillation. Students, you'll have learned two kind of SHM. Students, you'll have learned about linear SHM and you've learned about angular SHMs. Maybe SHM must have started. Is it started or going on, or what exactly it is?
It's finished in Blue House.
It's finished. You must have learned about this over there. Absolutely correct. The angular SHM ka definition formula. If I take a compass needle and if I suspend it freely, okay, and if I try to move its one end, and if I remove it, what happens? It starts oscillating in an external magnetic field. तो ये क्या हुआ? तुम्हारा Earth's magnetic field है. ये capital N क्या है? That is a magnetic dipole moment of the bar magnet. What is I? I is the moment of inertia of the bar magnet, and T is equal to under root I upon MB. And you can derive this relation. Students, the way you've derived simple pendulum का derivation ना, restoring force लेके, है ना? ये इसका T is equal to 2 pi under root L by G. इसका डेरिवेशन शायद तुम लोगों ने किया होगा फॉर लीनियर एसएचएम. तो वैसे ही इसका डेरिवेशन किया होगा इन टर्म्स ऑफ एंगुलर एसएचएम. ये फॉर्मूला यहाँ पे यूज करना है, बस फर्क क्या था? व्हाट एग्जैक्टली क्वेश्चन आंसर्स मैग्नेटिक मोमेंट यानी कैपिटल एम पूछा, स्क्वायर कर दो. टी स्क्वायर इज इक्वल टू 4 पाई स्क्वायर आई अपॉन मैग्नेटिक डाइपोल मोमेंट इनटू बीएच. पूछा क्या? मैग्नेटिक मोमेंट ऑफ द बार मैग्नेट यानी एम को सब्जेक्ट बनाना है. 4 पाई स्क्वायर आई upon t square into bh. Now see over here, are the terms given to you? Is current given to you? Sorry, is moment of inertia given to you? Yes, moment of inertia is given to you. Now this is in CGS. Agreed? This is in CGS. Time period always in seconds, 10 oscillations per minute. So frequency is what? Number of oscillations. Students, number of oscillations per unit time. What is time period? Reciprocal of frequency. So can I say 6 seconds? So time भी मिल गया तुम्हें. What's the horizontal Earth's magnetic field? 0.36 Gauss. And Gauss is a CGS unit. So ये भी CGS unit, ये भी CGS unit. Doesn't matter. Friends, is it clear?
Yes.
And the unit of this will be in CGS we consider. अगर तुम्हें MKs में convert करना है तो इसको convert कर लो. ग्राम सेंटीमीटर स्क्वायर को किलोग्राम मीटर स्क्वायर में convert कर लो. Gauss के हिसाब से 1 Tesla is equal to how much? 10⁴ Gauss. If I want my answer for capital M in ampere meter square, students, you should get the answer as 1.52. This is the answer. Students, is it clear to all of you all?
Yes.
Okay. Can I erase it now? Students, can I erase it? Okay, students. Now we go for the magnetic moment of an electron revolving around the nucleus. Okay. We are trying to go for a relation between magnetic dipole moment and angular momentum of a revolving electron. Friends, now when you speak about for the concept of magnetism or magnetic materials, when you speak about it, students, do keep in mind, students, we can consider that this is actually an assumption put forward by the physicist students. It is said that every electron, students, has two kind of motions associated with it. It has a spin motion, which you all know it, and it has an orbital motion. And physicists have assumed electron to be a electron having a magnetic dipole. They say that each electron is considered to be, listen carefully, students, each electron is considered to be or assumed to be having magnetic dipole. That means it has a north and a south. That's the assumption put forward by physicists. I repeat, each electron is assumed to be an imaginary magnet. Now, if I say an electron is an imaginary magnet, then it will certainly have a magnetic dipole moment, which is a vector quantity. Since it has two kinds of motions we consider, then the resultant magnetic dipole moment of an electron will be equal to the magnetic dipole moment due to the spin motion plus the magnetic dipole moment due to the orbital motion, students. I repeat, the resultant magnetic dipole moment of an electron is equal to the vector sum of the spin motion as well as the orbital motion. And this results in considering a substance to be a magnetic substance. Now, since we say that each electron is a magnet, then we assume that each atom is also considered to be a magnet. And that's an assumption. And therefore, we use the word atomic magnets. Students, अगर हर एक इलेक्ट्रॉन को मैं अगर मैग्नेट कंसीडर करता हूं, where do the electrons exist within an atom of an element? So each and every atom I'll consider to be a magnet. And these atoms, when they are considered to be in a given substance, what exactly they call? They consider to be magnetic domains. They collectively form magnetic domains. Now, a simple example, if I happen to consider, suppose if I happen to give you a substance which has a volume of 1 centimeter cube. In a volume of 1 centimeter cube, I can assume there are around 10 to the power of 23 atomic magnets, so called as atomic domains we consider. All these atomic domains are aligned in different regions. They aligned, we consider in different regions. Each region we consider has atomic magnets inside it, we consider. Har ek ke andar you have some amount. And how exactly these domains are aligned? They are aligned in different pattern. अगर suppose किसी magnetic domains का alignment, please pay attention, is in this form. Then what do I call the resultant magnetic dipole moment? I call the resultant magnetic dipole moment to be over here 0. Why? That means this arrowhead speaks about south, north, south, north, south, north, south, and north. Does it forms a closed loop? So vector sum of all the magnetic moments for this particular domain we consider is equal to 0. तो अगर इसका magnetic resultant magnetic moment 0 हो जाएगा तो क्या वो magnetic substance होगा? नहीं, we can call that as a non-magnetic substance. And that's how classification of substances comes into it. Your paramagnetic, diamagnetic, and ferromagnetic substances plays an important role in this manner. So either they form into a closed chain, whether in form of this, or you can go in form of a triangle. Simple, you have learned in vectors. Sum of vectors in same order in a given plane, and they are concurrent. The sum of all the vectors we consider is equal to 0. So यहाँ पे भी the resultant magnetic dipole moment यहाँ पे भी 0 होगा. So students, when you try to consider each and every atom is a magnet, then a student who is listening will say, sir, उसका मतलब आप ये बोलना चाहते हो कि periodic table में इतने सारे elements है, according to each and every atom is a magnet, तो सारे elements magnet है. Of course, I can consider all of them. So why is it so? Why is it so that a piece of wood doesn't get magnetized, but a piece of iron gets magnetized? Why is it so that a drop of water doesn't get magnetized, but an alloy alnico gets magnetized? The reason is because of these magnetic domain, students. When you find out the magnetic domains aligned in a closed pattern, enclosed we consider resultant is equal to 0, such substances are called to be non-magnetic substances. Students, your studies goes further ahead with respect to magnetic substance, and more precisely we consider ferromagnetic substance. The best example of ferromagnetic substance which must have learned in lower standard is also soft iron, having low percentage of carbon as compared to steel. Students, क्या ये part clear हुआ सबसे पहले? Yes. Is this clear? So now when you speak about it, please answer now. Whenever you're speaking about can a revolving electron behave like a magnet? Yes, we can have. And we can get a relation between magnetic dipole moment of a revolving electron as well as its angular momentum. This part is certainly there in your scope. ये तुम्हारे scope में नहीं है, फिर भी मैंने बताया कि reason क्या है. यानी हर एक element को हम magnet पकड़ सकते हैं. Students, we can consider. Few of them gets magnetized easily, few of them doesn't get magnetized easily, or it takes a longer time. If I happen to go for between temporary magnets and permanent magnets, students, temporary magnets are made up of soft iron, whereas permanent magnets are made up of steel, which you have learned in your lower standards. यानी वहां पे तुम करते क्या हो? फॉर एग्जाम्पल अगर मैं सॉफ्ट आयन के डोमेन्स देखता हूँ, स्टूडेंट्स ध्यान से देखना, सॉफ्ट आयन के डोमेन्स तो मैं देखूंगा तो अलग अलग रीजन्स है, सारे डोमेन्स डिफरेंट डायरेक्शन में अलाइन रहते हैं. स्टूडेंट्स, अभी सिंपल एग्जांपल आई कैन कंसीडर, थिंक ये एक रॉड है, सॉफ्ट आयन रॉड है. अभी देखो ये सारे एटॉमिक मैग्नेट्स हैं अलाइन रैंडमली, तो विल इट बिहेव एज अ मैग्नेट? नहीं सर, इसलिए हम इसको कंस्ट्रक्शन में यूज कर सकते हैं. A simple metal iron can be used for different purpose. But now suppose I have a magnet in my hand. Think this is a magnet in my hand. Okay, and I try to rub this magnet onto this piece consistently. तो वो कौन सा मेथड हुआ? सिंगल टच मेथड, which you have learned in your lower school level. Single touch method. अगर मैंने दो मैग्नेट्स लिया, डबल टच मेथड. Yeah. If I make a copper wire, and if I take a copper wire and make it to move around it, तो क्या बन जाएगा वो? Electromagnet. तो क्या कर क्या रहा हो? Due to current, yeah, due to single touch or double touch, what exactly you did? You try to force these atomic domains which were randomly aligned, all of them to move in one direction. Students, you aligned all these domains to move in one direction, we consider, resulting in formation of the substance to be as a magnetic substance. So this gets magnetized. हाँ, कुछ होते हैं टेम्परली मैग्नेटाइज, कुछ हो जाते हैं परमानेंटली. लेकिन वही चीज अगर तुमने पीस ऑफ वुड लिया, या वाटर मॉलिक्यूल लिया, या वुड लिया, या प्लास्टिक लिया, नॉन मैग्नेटिक सब्सटेंस, भले मैं कितना भी इसको रब करूं, या उसको मैं कॉपर वायर से वाउंड करके, अ पीस ऑफ वुड को कॉपर वायर से वाउंड करके, इफ आई गिव अ लार्ज अमाउंट ऑफ हेवी करंट, then too also you cannot break the closed loop over here. It's not one can break this loop easily in that case. Therefore, they all the time remain demagnetized. They do not undergo any kind of magnetization, students. But such kind of substances can undergo magnetization easily. So the main purpose for each atom is considered to be a magnet because each electron is assumed to be a magnet. Each electron is assumed to have a fictitious dipole, a north and a south. What kind of motions are associated with electron? There is a spin motion and the orbital motion. The resultant magnetic dipole moment is the spin motion, the orbital motion of the electron also we consider. Is this part clear with all of your students?
Yes, sir.
Okay. Okay, students. Now let us go for magnetic dipole moment and angular momentum of a revolving electron. Students, when you speak about for electron, if I make an electron to move, students, in an anti-clockwise direction, okay, so it is moving in a circular path around the nucleus of an atom of an element, students. Now, since it's moving in an anti-clockwise direction, students, what exactly the direction of its angular momentum, students? As per your Newton's rule, where exactly? The angular momentum का direction ऊपर की तरफ होगा. Motion of electrons in anti-clockwise direction. तो ये कौन सा होगा? Direction of angular momentum, students. Angular momentum being a vector quantity, students, and it's actually given by the formula for anti-clockwise motion. It's r cross p and not p cross r. ये ध्यान रखना, students. This is for circular path. Since the electron is performing, students, uniform circular motion, the angular momentum, which is perpendicular to the plane of revolution, we consider as agreed, is given by r cross p. If I want to write it in terms of its magnitude, what exactly we consider is r into m into v into sine theta. So can I say I can put it as mvr? This is angular momentum. So this is the angular momentum of the revolving electron. Now, when the electron is set to move in an anti-clockwise direction, can I consider the conventional current will be in the direction of resistance? What is the direction of conventional current? The direction of conventional current ये होगा direction of conventional current. तो अगर ये होगा direction of conventional current, तो direction of conventional current क्या होगा? ये clockwise दिख रहा है. Using clock rule, students, using clock rule. If the current is in clockwise direction, students, what's the polarity at the face of the coil will be? The polarity at the face of the coil will be south. यानी यहाँ पे फील्ड अंदर की तरफ जाए, नीचे की तरफ क्या होगा? नॉर्थ, यानी यहाँ पे फील्ड बाहर की तरफ आ। स्टूडेंट्स डू कीप इन माइंड, ये तुम्हारा क्लॉकवाइज है, एंड इफ आई एम मेकिंग यू टू सी द टॉप व्यू, तो ये साउथ है, इसके नीचे वाला नॉर्थ है। स्टूडेंट्स, how the field lines, the field lines are moving from where to where? From south to north. This is how the field lines are going. Field lines are going from south to north, we consider. So this is how the field lines. This is how the field lines is. They move from south to north, inside it. Externally, they move from where to where? North to south. Externally, they move from north to south. क्या ये डायग्राम क्लियर हुआ सबको?
Yes.
Students, is this diagram clear with you? I repeat, students, once again. Please, students, I'm repeating once again. Students, answer सुनना. Electron revolve कर रहा है in an anti-clockwise direction by using your right hand screw rule. My thumb is going perpendicular to the plane of the coil. We consider, sorry, plane of the revolution. We consider circular path. So angular momentum will be always along positive z axis, and it's given by r cross p for what kind of motion? Anti-clockwise motion. So angular momentum is mvr. Now, if this is your angular momentum we consider, then your conventional current is in the direction opposite to it. So looking at the conventional current, the top is your south, niche wala north hai. So it has a dipole, magnetic dipole we consider. So how is the magnetic dipole moment? So magnetic dipole moment, students, always keep in mind, is always directed from south to north. Always directed. And ye jo arrowhead dikha raha hai, ye hai direction of magnetic dipole. Now, if you carefully observe the two, magnetic dipole moment is along negative z-axis. This is along positive z-axis. So can I say they are opposite in direction? Let us find out a relation between the two. That's what we are trying to put forward. So do each revolving electron behaves like a magnet? Yes. It has a spin motion and the orbital motion. And more precisely, have gone for the orbital motion over here. That is more dominant. So यहाँ पे अगर मैं देखता हूँ, तो can you get a relation between them? Why not? You know the formula for magnetic dipole moment, students. Magnetic dipole moment is given by what formula? It's current into area. Students, please pay attention now. How to go about it? It's very easy. Magnetic dipole moment is current into area. How is current defined as? Rate of flow of electric charge. That means this is a charge on an electron we consider, and this is the time taken for electron to complete one revolution, which is periodic. What is the area, the face area of the coil we consider? That's pi r square I'll consider, and that's the radius of the circular path. Maybe the orbital radius I can consider, or the electron in the ground state, 0.53 angstrom. Ground state, electron revolving, 0.53 angstrom we consider. ये तुम्हारा आ गया pi r square. Now what I do, I need to get in terms of this. What I'll do, it's E into 2 pi r into r upon p into 2 multiply and divide by 2. Friends, what exactly is this distance upon time? See, the electron is covering the circumference. Length covered by the electron is equal to circumference of the circular path. This is time taken for one complete circumference, so that's a motion is periodic. What exactly distance upon time simply consider speed? So can I say simply EVR by 2? Please, you have MCQs, you have problems based on to this. ये numerical point के हिसाब से भी पूछते हैं. M is equal to EVR by 2 also. What does E stands for? Charge on an electron. What does V stands for? Velocity of the electron we consider. The electron is moving in anti-clockwise direction. This we consider as a tangential velocity we consider. This I'll consider as a position vector. For a circular motion, students, always V bar and R bar are mutually perpendicular to each other. The dot product will be always 0. देखो V और R कैसे जा रहे हैं, म्यूचुअली परपेंडिकुलर होगा at every position, तो इनका डॉट प्रोडक्ट हमेशा 0 ही आएगा. Now M is equal to EVR by 2. I want to get in terms of angular momentum. Angular momentum में क्या चाहिए, मुझे M चाहिए बस. What do I need to get? I need to get in terms of M. What do I consider? Your angular momentum is equal to mvr, which already know it. This is my equation number 1. This is my equation number 2. Agreed. Suppose if I try to go for the ratio, divide 1 by 2. So what is m by L? EVR by 2 and mvr. Do we have any cancellation? Yes, VR gets cancelled. What's my answer? E by 2. Therefore, students, what is the answer for magnetic dipole momentum and angular momentum, students? It's E by 2m. In vector form, if I want to write down, See the direction of these two. Are they in the same direction or opposite direction? Opposite direction. यानी अगर तुम वेक्टर फॉर्म में लिखोगे तो मैग्नेटिक डाइपोल मोमेंट स्टूडेंट्स it's minus E by 2m L bar. This is how we represent it in vector notation. So when you land up to a particular final answer, students do write on your answer in this form in your examinations, not in this form. Look over here, magnetic dipole moment. What is the magnetic dipole moment? So it's in the direction opposite. Negative sign shows direction opposite. To whom? The angular momentum, which is along positive z axis. Is this clear to all of you?
Yes.
Yes. Now, what exactly E by 2m we simply call? Students, E by 2m simply they have called as a gyromagnetic ratio. This term, if they ask you, what is E by 2m, students? So E by 2m simply is called as what? E by 2m, students, is called gyromagnetic ratio. Students, ये constant है. E by m तो सबको पता है. What is E by m? Specific charge of an electron. Students, specific charge of an electron. Structure of atom में पढ़ा होगा. या न्यूक्लियर फिजिक्स में पढ़ा होगा, रेडियो एक्टिविटी में पढ़ा होगा. E by m. तो E by m क्या है? चार्ज पर यूनिट मास 1.6 into 10 to minus 19 upon 9.1 into 10 to the power of minus 31. तो इसको अगर मैं डिवाइड बाय 2 करता हूँ, E by 2 हम भी कंसीडर इन दैट केस, तो क्या होगा? 8.8 into 10 to the power of 10 coulomb kilogram inverse. That's the ratio of E by 2m. Is this clear, students? It's a constant value. It's called as a gyromagnetic ratio. Same concept, you will have learned it into your structure of atom. Maybe that was the initial topic which you must have done in class 11th. Students, do you recollect your Bohr's postulates? The first postulate, second postulate, and the third postulate. What exactly the second postulate speaks about? Anybody can tell about the second postulate?
The angular momentum is quantized, NH by 2 pi.
The angular momentum of the revolving electron is always conserved. It's an integral multiple of h upon 2 pi. That means those electrons revolving specific orbit, okay, they do not radiate energy in that particular orbit we consider. And their angular momentum, what exactly have learned it? Their angular momentum, students, is an integral multiple of h upon 2 pi, and it remains constant, where n is the orbit number we consider, okay, or the principal quantum number. H we consider is Planck's constant, 6.63 into 10 to the power of minus 34 joule second, 2 pi. Now, students, can you get a relation for this in terms of magnetic dipole moment in terms of this? देखो ना, L को substitute कर दो. NH upon 2 pi. So what exactly my answer for M? E by 2m into L के जगह पे क्या लिखोगे? NH upon 2 pi. So can I say my formula will be what? NEH upon 4 pi N. Friends, this is the formula for Bohr's magneton. When they ask you for n equal to 1, students, for n equal to 1, what's the Bohr's magneton for the ground state? Put n equal to 1. E constant, H constant, M constant. And when you substitute this value, students, you'll be getting the answer as 9.274 into 10 raised to minus 24. 274 into 10 raised to the power of minus 24 ampere meter square inverse. Ampere meter square current into area. Magnetic dipole moment. Students, क्या ये clear हुआ, students? Everyone? Students, is it clear?
Yes.
L is equal to NH upon 2 pi. Simply just substitute it. What do you call this as? This is called as Bohr's magneton. And the formula is NEH upon 4 pi MB. Okay. So when they ask you for the concept related to a revolving electron, students, these all things the students should know it. A simple diagram, you should know it. Okay, where you should say that L and M are in opposite direction. बस उतना ही तुम्हें बताना. This is the magnitude E by 2m. This is negative sign shows, this is negative sign. Capital M is negative E by 2m. Negative sign shows that magnetic dipole moment and angular momentum are both are in opposite direction. This negative, this is in vector form, shows that they are in opposite direction. E by 2m का ये है magnitude 8.8 into 10 to 10 coulomb kilogram. If I put n equal to 1, then Bohr's magneton for the first orbit is 9.274 into 10 to minus 24. Can I erase this, students? Students, can I erase it? Okay, students, let us go for now the next concept, magnetization and magnetic intensity. Students, we are now trying to understand how exactly a substance gets magnetized. Okay, so all of you all know it that if I go for any kind of substance, it has certain magnetic domains. Now, if somebody asks you what exactly a domain is, तो तुम्हारा answer होना चाहिए, it's a region consisting of atomic magnets. If I say a size of 1 centimeter cube, do you have some atomic magnets inside it? Yes, collectively they are very large. For a given substance, how are these domains are? Then your answer will be it can be in a closed loop or they can be randomly aligned. If they are in a closed loop, then will that particular substance will get magnetized? Then your answer should be no, because the resultant magnetic dipole moment will be zero. But if I say there is a random orientation of these kind of domains, then what exactly we can consider the atomic magnets? Then what exactly? Then by simple electrical methods, we can make all the domains to get aligned in one direction. We are trying to understand the concept of how to make a substance gets magnetized. That is called magnetization of a substance. Magnetization का मतलब क्या? जो substance को तुम कैसे magnetize करोगे? या magnetization है क्या? और उसका किसका help चाहिए तुम्हें in order to magnetize it? So now if I happen to speak about the first concept, students, about magnetization, students, magnetization, MZ, students, okay, is defined as the ratio of magnetic dipole moment, since magnetic dipole moment of the substance to the volume of the material. That means magnetization is defined as the ratio of magnetic dipole moment, magnetic dipole moment per unit volume of a given substance. Now this answer is always in ampere meter square. नीचे मीटर क्यूब में होगा, तो what exactly magnetization का unit क्या होगा? Will be equal to what? Ampere meter inverse, mz. Students, see, when you try to refer your books also, you might come across some different variables. Now it depends on you students, how do you make your variables more easy? अगर मैंने कैपिटल M मैग्नेटिक डाइपोल मोमेंट के लिए रखा है तो मैग्नेटाइजेशन पे Z आता है, इसलिए मैंने MZ रखा है, तो आई कैन डिस्टिंग्विश वेरी क्लियरली. MZ will be for magnetization, capital M will be for magnetic dipole moment. Magnetic dipole moment has its own formula, current into area we consider, per unit volume we consider. क्या ये क्लियर हुआ स्टूडेंट्स? Students, is this clear? For a given volume of
Yes,
a given substance, how many substance gets magnetized easily? And that depends on to magnetization. Now, if somebody asks you students, what exactly? That means answer suna, students, listen carefully. Suppose agar, please pay attention students. Suppose agar मैंने कोई iron rod लिया, please everybody be with me. Yeah? If I happen to go for a magnetic substance, it's going to say there are lots of magnetic domains inside it. So now suppose if I ask you, what does, listen carefully, what does magnetic field strength? The answer suna students. What does magnetic field strength or magnetic field intensity or magnetic induction of a magnetic material depends? तो तुम बोलेगा सर मैग्नेटिक इंडक्शन, ध्यान से सुनना, मैग्नेटिक इंडक्शन ऑफ अ गिवन मैग्नेटिक मटेरियल, सर ये तो डिपेंड होगा ऑन टू इट्स मैग्नेटाइजेशन. हाँ क्या ना?
yes, sir.
यानी जितने डोमेन्स अलाइन होते हैं इन दैट पर्टिकुलर वॉल्यूम उतना वो ज्यादा पावरफुल हो जाएगा. अगर कम डोमेन्स अलाइन होते हैं पर यूनिट वॉल्यूम तो कम मैग्नेटाइज होगा. तो इट डिपेंड्स ऑन टू व्हाट? मैग्नेटाइजेशन ऑफ दैट पर्टिकुलर सब्सटेंस. क्या ये क्लियर हुआ सबसे पहले? So B for a medium is directly proportional to BZ, we consider. If I want to remove the symbol of proportionality, students, what exactly I can consider over here? Sir, over here you'll get B for a medium is equal to mu naught into MZ. What does mu naught stands for? Permeability of free space, the surrounding medium. Where are you trying to magnetize the substance? It depends on the surrounding medium. Are we trying to make the substance to get magnetized in air? Or are you trying to keep it into certain external magnetic field, or in vacuum you are trying to create it? That all depends on the surrounding medium. तो क्या ये पहला mathematical relation clear हुआ students? Please, I'm giving you all basic things to understand a very important mathematical relation which is going to come further ahead. Many students don't get that part of it, but to understand this is very easy to get it. First of all, I told you about magnetization. Magnetization of a substance depends on to what? It's the magnetic dipole moment. That means alignment. Alignment. It will be the alignment we consider for the magnetic substance we consider. Okay. It depends on the alignment of the substance we consider in this case. What happens? Somebody is posting what? Wait a minute. No, my dear. Mu zero is a surrounding medium we consider in which the substance is getting magnetized. Then you have a relation, na? You have a relation with respect to the external. तो यहाँ पे तुम्हारा स्टूडेंट ये जो MZ है ये magnetization है, and that's a ratio of the number of dipoles getting aligned per unit volume. Okay, that's magnetization. और जितना magnetization बढ़ेगा उतना B for that medium also will increase. Considering the surrounding medium mu zero we consider. क्या ये क्लियर हुआ सबसे पहले? हाँ स्टूडेंट्स?
Yes, sir.
My dear, Jagannath, I've taken a magnetic substance only. I've taken a substance itself only. Are you getting it? So the substance itself has domains inside and they're getting aligned. They're getting aligned in that case. एक simple example dances to students. एक second हाँ. Jagannath is trying to raise a question कि sir इसका आपने ये mu zero क्यों लिखा? Mu for a medium क्यों नहीं लिखा? Are you getting it? Jagannath मुझे ये बता, what are magnetic keepers? What are magnetic keepers? चलो ये बताओ मुझे. Magnetic keepers यानी suppose तुम्हारे पास कोई अगर magnet होगा ना, the way you see it over here. These are all magnets. These are all magnets. अगर मैग्नेटिक कीपर्स, अगर तुम्हें मैग्नेट्स को स्टूडेंट्स अगर अच्छी तरह से रखना है तो कैसे रखोगे तुम? कोई भी मैग्नेटिक सब्सटेंस के साथ में ये तुम्हारा मैग्नेट है, ट्राई टू फिक्स एन आयरन रॉड भी कंसीडर, और बीच में वुड रखो, ये पूरा वुड है, ये तुम्हारा मैग्नेट हुआ, यानी क्या हुआ? ये नॉर्थ है, साउथ है. Are you getting it? तो क्या होगा? ये जो आयरन रॉड है और ये जो आयरन रॉड है वो क्या? These are called मैग्नेटिक कीपर्स along with wood in between. तो क्या होगा? एक क्लोज लूप फॉर्म हो गया. नॉर्थ साउथ, तो यहाँ का क्या बनेगा? व्हाट एग्जैक्टली इट विल फॉर्म इनटू? अगेन दिस विल बी नॉर्थ, दिस विल बी साउथ. तो इस मैग्नेट का मैं यहाँ पे क्या रखूंगा? नॉर्थ साउथ रखूंगा. ये भी नॉर्थ साउथ. इज इट फॉर्मिंग अ क्लोज लूप? देखो, साउथ टू नॉर्थ, साउथ टू नॉर्थ, साउथ टू नॉर्थ, साउथ टू नॉर्थ. रिजल्टेंट मैग्नेटिक फील्ड इंटेंसिटी 0. तो यहाँ पे मीडियम का कहाँ पे है इन दैट केस? हाँ, वो बात है कि इफ इन केस इफ आई ट्राई टू कीप इट विद अदर सब्सटेंस अराउंड इट, then it depends on to that. So what exactly I try to put forward is that magnetic induction for a particular medium depends on its magnetization. And we are trying to go for magnetic substance itself only. Is it clear? Okay, now please pay attention, students. Now if I happen to go for the next concept, students, what exactly magnetic field intensity we consider? Okay. If I say magnetic intensity, students, this is H. Magnetic intensity. And students, the unit of magnetic intensity, if you consider, it's simply ampere meter inverse. And that is equal to number of turns per unit length into current flowing through it. Please concentrate on this part of it. Magnetization depends on the dipoles per unit volume. How do I make the dipoles to get aligned? How do I get the dipoles to get aligned? Due to the external help. What is the external help I'm taking it? Magnetic intensity. What is magnetic intensity? It's N into I. What does N stands for? N stands for number of turns per unit length. So current is in ampere, and this is ampere meter inverse. This is the relation for magnetic intensity, students. Yani students, now Jagannath, magnetization of this material depends on to what? अभी देखो, अभी जगन्नाथ, अभी तुम्हारा आ गया आंसर. Magnetization of this material किसके ऊपर डिपेंड होगा? Sir, it depends on to what? Magnetic intensity. Everybody be with me for another 1 minute. ध्यान से सुनना. मैंने एक सॉफ्ट आयरन रॉड लिया. Everybody be with me. तो इसके अंदर क्या हो गया? डोमेन्स है ना? सारे डोमेन्स कैसे हैं? रैंडमली अलाइंड है. क्या वो मैग्नेट बन सकता है? हाँ, बन सकता है ना. अगर मैंने पूछा how can you make what exactly the resultant magnetic induction of this medium, तो तुम क्या बोलोगे? So the resultant magnetic induction will be equal to mu naught into mz. Mu naught is a surrounding medium where you are trying to perform it. mz उसका मैग्नेटाइजेशन. अभी उसका मैग्नेटाइजेशन किसके ऊपर डिपेंड है? तो एक स्टूडेंट क्या कर रहा है? मैग्नेट लेके उसको सिंगल टच मेथड से करते रह रहा है और उसको मैग्नेटाइजेशन बना रहा है. दूसरा बंदा क्या कर रहा है? डबल टच मेथड से ले रहा है और उसको मैग्नेट बना रहा है. लेकिन तीसरे ने क्या किया? तीसरे ने स्मार्ट मूव कर दिया. क्या कर दिया? उसने कॉपर वायर लिया और उसको टर्न्स करने लगा और फिर उसने सर्किट को कनेक्ट कर दिया. तो आया ना ये, आया ये नंबर ऑफ टर्न्स पर यूनिट लेंथ एंड द मैग्नीट्यूड ऑफ करंट फ्लोइंग थ्रू इट. अगर मैंने आई बढ़ाया अगर मैंने नंबर ऑफ टर्न्स बढ़ाया है तो इंटेंसिटी ऑफ मैग्नेटाइजेशन बढ़ेगा. अगर इंटेंसिटी ऑफ मैग्नेटाइजेशन बढ़ेगा तो व्हाट एग्जैक्टली मैग्नेटाइजेशन, वो भी बढ़ेगा. नाउ स्टूडेंट्स, योर मैग्नेटाइजेशन ऑफ द मटेरियल डिपेंड्स ऑन टू द सब्सटेंस and that is called susceptibility. Chi. Friends, how do you pronounce this as chi? इसको हम बोलते हैं susceptibility. ये तुम्हारा मीडियम के ऊपर डिपेंड होगा. समझ में आया? फ्रेंड्स, इतना क्लियर हुआ? A person who gets this clear will be able to get the derivation now very properly. Then you say, acha, and mind you, this is a slightly tricky derivation. Huh? Many students forget also very fast. But if you try to understand in a flow, you'll be able to keep it lasting. The time when you're doing the same chapter with Hemant sir or Som sir, you'll be able to click it. Arey, haan yaar, wahan pe hum log ne kiya hua tha. You'll be able to. So many students get confused with this. कहाँ पे काय यूज करना है, कहाँ पे म्यू जीरो यूज करना है, कहाँ पे mz लिखना है, कहाँ पे m लिखना है, कहाँ पे ni लिखना है, किसको कहाँ पे डालना है, कुछ पता ही नहीं चलता. And that's why students hate this part. Magnetic materials का part they hate. Yes. Students, can I proceed now further? Students?
Yes, sir.
Yes, sir.
But please don't rub.
No, I'm just going to erase this part. I'm just erasing this part. Okay. Yeah, part. This symbol we consider is chi, chi. Okay. This is a Greek alphabet we consider. And this speaks about magnetic susceptibility for a given substance. The magnetic susceptibility is different for different substances. And that's how it comes under the classification of substances we consider. So now when you look into it, the magnetic induction, this simply stands for magnetic induction, students. The magnetism induced, listen carefully, magnetism induced, getting it, in this magnetic material depends on its magnetization. Magnetization depends on its magnetic intensity. And magnetic intensity is the method with which we can make a substance get magnetized, N into I. And this is the fastest way to get it. You can't do single touch method, double touch method. Electrical method is the one which you have to consider all the time. That's how physicists go for electrical methods. And that's how electromagnets are considered. So this is what we consider. Now let us go for the students. Answers. Okay. Suppose now, if I happen to consider air or solenoid. Can you give me the formula for the magnetic induction? The answer is in a magnetic induction induced in this air core solenoid. Chalo, apna dimag laga ke get me the answer. The magnetic field intensity in an air core solenoid. तो तुरंत तुम बोलोगे सर लास्ट लेक्चर में आपने सोलेनॉइड दिया था, आपने मैग्नेटिक फील्ड इंटेंसिटी फॉर अ सोलेनॉइड पूछा था और यहाँ पे आपने एक्सिस दिया था, तो यू सेड इट फॉर इनसाइड, इनसाइड के लिए ही जाएगा. आपने सिर्फ क्या किया है, हमें थोड़ा सा और ऐसा ज्यादा स्मार्टनेस दिखाने के लिए एयर कोर सोलेनॉइड बोल दिया है. एयर कोर का मतलब क्या, अंदर हवा है, ऑफ कोर्स कुछ दूसरा सब्सटेंस तो है ही नहीं. तो सर इसका तो फॉर्मूला सिंपली V0N/I आएगा. अरे हाँ सर, N stands for what? Number of turns upon length of the solenoid. अरे हाँ सर, ये तो पहला वाला है तुम्हारा. Agreed? Agreed? Now, if I happen to take a piece of soft iron, the answer सुनना ना. If I happen to take a piece of soft iron, agreed? Then what exactly the magnetic induction induced in this medium of soft iron? Then you will say, sir, magnetic induction induced in the soft iron depends on to what? Magnetization. What is magnetization? Magnetic dipole moment per unit volume into mu zero. क्या ये clear हुआ सबको?
Yes.
Do keep in mind students, n into I is what? H. ये भी ध्यान रखना। अभी देखो ये तुम्हारा फर्स्ट वन, ये तुम्हारा सेकंड। अभी देखो अगर सपोज एक स्टूडेंट को मैंने बोला कि जस्ट ट्राई टू टेक एन एयर को सोलेनोइड एंड ट्राई टू परफॉर्म योर एप्लीकेशन, चलो एक डिवाइस बनाओ, ओके कुछ इन्वेंट करो इससे। और दूसरे को मैंने बोला टेक अ सॉफ्ट आयरन स्टूडेंट एंड ट्राई टू टेक दिस वायर एंड देन बाउंड ऑन टू इट एंड देन ट्राई टू मेक अ एप्लीकेशन डिवाइस. Which one will have a stronger magnetic field? The one with air core or one with material and then having soft copper wire bound onto it? You'll say, sir, it's medium के साथ वाला. पहला तो सिर्फ air core था, तो उसका magnetic field strength कम होगा ना स्टूडेंट्स. अभी मैं क्या कर रहा हूँ? अभी मैं soft iron ले रहा हूँ स्टूडेंट्स. सेकंड में मैंने क्या किया? I'm slightly shifting the diagram now. I'm shifting the board. This part now I'll be using it. Now students, what am I trying to do? I'm trying to take this particular soft iron. Agreed? And on the soft iron, what exactly I try to go for? So you try to go for a wire wound onto it. है ना? तो ये क्या हो गया? This becomes a solenoid. But now, what kind of a solenoid it has? What kind of it? Sir, the resultant magnetic field induction, the magnetic induction resultant will be due to the magnetic field induction due to the air core plus due to medium. क्या ये clear हुआ? दोनों का addition हो जाएगा?
Yes, sir.
Now suppose if I happen to get a mathematical equation, now ये पूरा derivation clear हो जाएगा. सामने सब formulas हैं. अभी अपने आप से डालते रहो. So what exactly B resultant? So B resultant is B0. B0 क्या होगा सर? mu naught NI. B for a medium क्या होगा? Mu naught MZ. Is that clear? Can I say NI is equal to H? So B is equal to mu naught into H plus mu naught into MZ. Is that clear?
Yes.
Now suppose if I ask you what is MZ? What is MZ? Chi into H. Magnetization of a magnetic substance depends on to what? Magnetization of the soft iron depends on to what? किसके ऊपर डिपेंड होता है? It depends on to the number of turns increase. अगर मैं ज्यादा number of turns लेता हूँ, if n increases, so if n increases, and if I make current to increase, what about H? H will increase, Mz will increase. So can I substitute Mz over here? तो क्या formula? B is equal to mu naught H plus mu naught की जगह पे क्या है? It's chi H into Mz. What exactly B is equal to? Mu naught we consider plus H we consider common. Is that clear? Plus pi into mz. Is this clear? Sorry. This is H common, friends. If I happen to consider mu naught into H, I'll consider. Okay. So now if I happen to consider mu naught is equal to what? Sorry, mz nahi aayega. Mu naught aayega. So now mu naught into bracket what exactly? 1 plus pi into H. क्या ये clear हुआ सबको? Friends, I'm substituting mz as pi into H. Okay. ये substitute कर दिया मैंने. So देखो, B is going to be not 1 plus chi into H. See, students, 1 plus chi stands for what? It's called as relative permeability. This is permeability of free space is equal to B into H. This mu naught into mu R simply stands for mu for medium, which Jagannath was asking. Students, try to understand relative, please pay attention students, relative permeability we consider is defined as permeability we consider a free space to permeability of a given we consider is in terms of medium we consider medium to with respect to free space. See students, relative permeability is permeability of medium to permeability of free space we consider. The product of these two we consider will be mu. Exactly you must have learned it in your epsilon we consider. Relative permittivity. इलेक्ट्रोस्टैटिक्स में पढ़ा होगा, relative permittivity of a medium students is equal to permittivity of a medium upon permittivity of free space. This is how we consider mu average will be for a medium upon mu zero. तो ये तुम्हारा फॉर्मूला है. So the resultant, ध्यान से सुनना, the resultant magnetic induction for air soft ion core solenoid, or for a solenoid, core solenoid we consider, is mu for a medium into H. What does H stands for? Magnetic intensity. Since क्या ये derivation clear हुआ?
Yes.
इसके related problems they will ask you. So once again, students, do keep in mind, mu for a medium is directly proportional to mz we consider. Magnetic intensity is n into I we consider. Magnetization is proportional to H, time to H. Time stands for susceptibility, depends on the medium we consider. If I happen to substitute back over here, mz को मैंने substitute कर दिया, तो मेरा H common आ गया, V0 common आएगा, 1 plus chi, and 1 plus chi is mu r, relative permeability. Relative permeability, students, is defined as the ratio of permeability of medium to permeability of free space. Can I erase this now?
1 minute, sir.
So before going for those derivation, students, ये तीन formulas बहुत ध्यान में रखना. ये तीन formulas अगर तुम्हें ध्यान में, then you try to go for these two formulas separately, and then try to overlap each other, and then go for the resultant magnetic induction, and simply substitute the formulas.
Sir,
Yes.
psi is called susceptibility of free space.
Magnetic susceptibility.
Only magnetic susceptibility.
Yes.
Okay.
Yes. You have electric susceptibility also, but you go for magnetic susceptibility in this case.
Done, sir.
Okay. Thank you, students. Now, when I speak about with respect to the susceptibility students, it is said that for diamagnetic students, you keep in mind, okay, the magnetic susceptibility be considered for students diamagnet, okay, paramagnet, and ferromagnet substances students. For diamagnet students, its susceptibility we consider is of the order 10 to the power of -3. Okay, it's in negative students, okay? Negative 10 to the power of -3 to negative 10 to the power of -5. For paramagnetic, it is 0 to 10 raised to 3 students. 10 raised to -3. And this will be simply positive, thousands. 100 to 10 raised to 3. यानी ये है तुम्हारा magnetic susceptibility for each we consider. For diamagnetic, paramagnetic, and ferro. This is negative and very small we consider in this case. Okay, this is the range we consider. और यहाँ पे 0 to -3. From here we come to conclusion that which are best substance we consider. Ferromagnetic substance is a good one. A simple example of we consider is diamagnetic substance, students, if you consider is copper. Okay, diamond. Just keep in mind in this case, diamond we consider. Mercury, nitrogen. Am I getting it? Over you can go for paramagnetic substance, you can go for aluminium. Okay, oxygen, platinum. If I happen to go for ferromagnetic substance, we consider is soft tan we consider. Okay, nickel, cobalt, and alloy alnico, nippermag. These are the examples. So when you try to go for substances, yes, we can classify substances, students, into di, para, and ferro. Now I'm just giving you simple distinguishing features of all students. Okay. And this is what just keep in mind, students, over here. Okay. Abhi ध्यान से सुनना. अगर किसी ने पूछा what is the cause for magnetism, students? If I happen to go for cause for magnetism. Cause for magnetism, students, if you want to go for it, then simply we can consider is for diamagnetic substance, it's only due to the orbital motion of electrons we consider. For paramagnet, we go for precisely spin motion of electrons we consider. And ferromagnet is due to formation of domains. Your study, students, goes precisely with ferro, not with para, not even with di. That is the domain structure we consider over here. Okay. They get poorly magnetized. Even both of them get poorly magnetized. Students, this gets strongly magnetized. Yani, agar tumne B for medium likha for this one is less than B we consider due to the external magnetic field. It's very small when you have an external. And suppose if I give an external magnetic field, students, ये जो है ना, ये external magnetic field है. ये external magnetic field है. अगर तुमने इस object को तुमने external magnetic field तो it's very small. इसका जो magnetic field है इससे greater है. ये क्या होगा? So this is much more greater. We can say that means its magnetization is much more faster and stronger. We consider. If in case if I happen to give you a relation, graphical relation of intensity of magnetization, so it's intensity of magnetization with magnetic intensity. So can I say it's directly proportional? What's the formula? Chi into H, and the value of chi, you know it. तो यहाँ पे तुम्हारा आंसर क्या होगा सर? यहाँ पे अगर मैं ग्राफिकल रिप्रेजेंटेशन प्लॉट करता हूँ, ध्यान से सुना स्टूडेंट्स, तो व्हाट इज माय स्लोप? माय स्लोप इज नेगेटिव. यानी अगर मैं mz यहाँ पे लेता हूँ स्टूडेंट्स और h यहाँ पे लेता हूँ, माय स्लोप विल बी नेगेटिव. प्लीज ट्राई टू अंडरस्टैंड दिस पार्ट. स्टूडेंट्स, आर यू गेटिंग दिस? Magnetization is directly proportional to what we consider as magnetic intensity. अगर मैं proportions में निकाल दूं तो मुझे क्या आता है? Constant आता है. ये constant क्या है? Magnetic susceptibility. तो ये क्या है? इसका नेगेटिव स्लोप है. ये वाला आएगा. इसका क्या होगा स्लोप? वी कंसिडर. सो दिस इज 0 to 10⁻3. दिस इज समथिंग पॉजिटिव वी कंसिडर. यहाँ पे अगर मैं if I happen to go for magnetization, we consider with magnetic intensity, my slope will be positive. यहाँ पे it's very large. Friends, यहाँ पे अगर तुम देखोगे mz और h, my slope will be very large. In this case, the graph will be curved, but it will be very large. And it's positive. 10⁻2 to 10⁻3. Students, क्या ये clear हुआ सबको?
So what did you explain before this? I actually disconnected.
No, I was trying to just classify substances into diamagnetic, paramagnetic, and ferromagnetic substances. And the reason for having diamagnetic, paramagnetic is the orbital motion, spin motion we consider. This is for the domains which has both the orbital and the spin motion collectively. When you try to keep an external magnetic field, तो इसका magnetism बहुत ही weak होगा. इसका थोड़ा सा ज्यादा होगा, उसका बहुत ही ज्यादा होगा। गिविंग यू एग्जांपल्स। ये जो सबसे ज्यादा इंपॉर्टेंट स्टूडेंट्स तो ये ध्यान रखने, ये पार्ट और ग्राफ का। If you want, you can keep examples also. You can keep in mind. If you do examples, if they ask you. यहाँ पे मैंने क्या दिया एग्जाम्पल में, मैंने magnetization is directly proportional to what? Magnetic intensity, which I told you, and that depends on the material, that is susceptibility. अगर तुम देखोगे तो it's -10⁻³ to -10⁻⁵. That means what exactly? My value of pi is negative. Slope is negative, so the graph will be in the fourth quadrant. यहाँ पे मैंने magnetization with magnetic intensity लिखा, तो यहाँ पे मेरे को पॉजिटिव ग्राफ आ। ये बहुत ही ज्यादा फेरो, so the graph will be curved but inclining to a great extent, we consider. Is this clear to all of you all?
Yes, sir.
Yes, sir.
Okay. Now when I try to go for further ahead, this is actually the curve part which you have to keep in mind, students. Okay. Now when you speak about with respect to temperature, students, dance is when you go for temperature, what happens when you try to take this particular diamagnetic substance and if you try to heat it? Okay. So students, जैसे तुम इसको हीट करोगे तो उसका मैग्नेटिक ससेप्टिबिलिटी क्या होगा? उसका मैग्नेटिक ससेप्टिबिलिटी स्मॉल एंड नेगेटिव। स्टूडेंट्स, diamagnetic का magnetic susceptibility is small and negative. ये है dependence on temperature. So यहाँ पे के स्टूडेंट्स क्या होगा मालूम है? टेम्परेचर इंडिपेंडेंट है, यानी susceptibility of diamagnetic substance is independent of temperature. अगर मैंने कोई diamagnetic substance लिया और मैंने हीट किया तो what exactly my graph will be? So my graph will, ये तो नेगेटिव में ही आएगा ना स्टूडेंट्स। हेलो, ये देखो, और ये टेम्परेचर एक्स एक्सिस में लिया, व्हाट इज काई फॉर डायमैग्नेटिक? नेगेटिव। तो मेरा ग्राफ क्या होगा? कांस्टेंट रहेगा। मेरा आंसर नेगेटिव में रहेगा, लेकिन यानी टेम्परेचर में बढ़ा ना स्टूडेंट्स, बट इट्स ससेप्टिबिलिटी डज नॉट चेंज, इट रिमेंस कांस्टेंट। यहाँ पे पैरामैग्नेटिक के लिए स्टूडेंट्स, द मैग्नेटिक ससेप्टिबिलिटी we consider is it's small and positive. Students, it is small, value is 10⁻³ लेकिन आगे देखो कौन सी वैल्यू है? पॉजिटिव एंड पॉजिटिव। तो यहाँ पे क्या होगा? अगर तुम टेम्परेचर बढ़ाते हो तो उसकी ससेप्टिबिलिटी कम हो जाएगी। दैट्स व्हाई दे ट्राई टू गो फॉर डीमैग्नेटाइजेशन के अंदर। यानी सपोज अगर पैरामैग्नेट को डीमैग्नेटाइज करोगे तो वो कौन से फॉर्म में हो जाएगा? डाई में कन्वर्ट हो सकता है। कैन यू कन्वर्ट पैरा टू डाई? व्हाई नॉट? हीट इट। हाउ इज इट मैग्नेटिक ससेप्टिबिलिटी? इनवर्सली प्रोपोर्शनल टू टेम्परेचर, and this is what we call Curie law. Curie law states that the magnetic susceptibility of paramagnetic substance, the answer to another statement, the magnetic susceptibility of paramagnetic substance is inversely proportional to the absolute temperature, students. Now, if I happen to plot a graph of temperature versus magnetic susceptibility, inverse variation, students, what kind of a graph will be getting? So the graph will be hyperbola. जैसे जैसे टेम्परेचर बढ़ेगा मैग्नेटिक ससेप्टिबिलिटी कम होते जाएगा। क्या ये क्लियर हुआ स्टूडेंट्स?
Yes.
व्हाट अबाउट फेरोमैग्नेटिक सब्सटेंस? सर फेरोमैग्नेटिक सब्सटेंस के अंदर जो मैग्नेटिक ससेप्टिबिलिटी वो क्या है? सर इट्स पॉजिटिव एंड वेरी लार्ज। स्टूडेंट्स, chi for ferromagnetic is what? Is positive and very large. See how to ये चीज को इजी कैसे बनाते हैं मालूम है स्टूडेंट्स? पढ़ने के लिए भी try to go for tabular column and try to remember in this manner. Put all the points one below the other, that becomes much more easier. And they are temperature dependent. They are temperature dependent, we consider. How is it? The magnetic susceptibility of ferromagnetic substance is reciprocal of T minus Tc. What does Tc stands for? Students, Tc stands for Curie temperature. Everybody please listen carefully. Tc stands for Curie temperature. Yani, ध्यान से सुनना students. Now suppose if I plot a graph, everybody give it me now. Please do it. This is temperature. This is magnetic susceptibility. यहाँ पे मैं Curie temperature देता हूँ students. Okay, please pay attention. As temperature goes on increasing, what's going to happen to this magnetic susceptibility we consider is? What happens? T minus Tc we consider. Your T is this minus Tc we consider will increase. At a particular temperature, what happens? The susceptibility reaches to its maximum. But now when I increase the temperature beyond Curie, students, if I increase my temperature, this is, please students, this is T less than TC. And this is T greater than TC. क्या होगा? Magnetic susceptibility कम हो जाएगा. students, तो यहाँ पे तुम्हारा declining graph होगा, यहाँ पे तुम्हारा inclining graph होगा. This is inclining and this is declining. Students, Curie temperature, students, is the temperature at which a ferromagnetic substances can be converted into a para temperature above Curie. देखो ये ग्राफ देखो और ये ग्राफ देखो, है ना, दोनों में सिमिलरिटी है कि नहीं है? यानी अगर तुम Curie टेम्परेचर को एक्सीड कर लेते हो तो तुम्हारा फेरो क्या बन सकता है? पैरा बन सकता है. Example for iron, what exactly the Curie temperature is? For iron, the Curie temperature is 770 degrees Celsius, which is equal in Kelvin is how much? 1043 Kelvin. Students, इसका एक simple example है. A simple example. Forget about this. Just try to take a. अगर suppose I have a magnet over here. अगर suppose मैं magnet को मैं धागे से बांधता हूँ, students, try to understand this very clearly. Then I take 3 balls. एक बॉल के अंदर मैं I'll put some stapler pins. दूसरे बॉल में मैं एकदम गर्म पानी रखता हूँ, उबलता हुआ. और तीसरे में मैं थोड़ा सा ice water रखता हूँ, मैं ice water. And then I take this particular magnet. Okay. In the first case, if I take the magnet and take it to the iron filings or whatever it is, iron staplers, they'll stick to it. They'll attach with it. फिर मैं निकाल देता हूँ. फिर मैं क्या करता हूँ? उसी मैग्नेट को मैं गर्म पानी में रखता हूँ. यानी जब तक उसका टेम्परेचर स्टूडेंट्स क्यूरी से कम है, it will behave like a magnet. लेकिन जैसे उसका temperature it goes above that, what happens? It starts demagnetizing. Means what happens to the domains? What happens to the domains, students? The domains which has initially got aligned, at a temperature greater than Curie, what happens? Again they go random. यानी they get demagnetized to para. तो जैसे मैंने उसको गर्म पानी में रख दिया तो what happens? गर्म पानी में रखने से क्या हुआ? तुमने डोमेन्स का अलाइनमेंट को तोड़ दिया. सारे डोमेन्स वापस फ्लिप होके रैंडम आ गए. फिर तुम उसको वापस आयन फाइलिंग्स के नजदीक लेके जाओ, आयन फाइलिंग्स क्लिंग नहीं होंगे. लेकिन वापस उस मैग्नेट को वापस तुम ठंडे पानी में लेके जाओ तो वापस तुमने उसका टेम्परेचर कम कर दिया. T is less than this we consider. So what happens in that case? अगर टेम्परेचर कम हो जाएगा, what happens? They will start aligning themselves again. And that is what we consider the magnetic susceptibility for ferromagnetic substance is a reciprocal of T minus Tc, where T is a temperature provided to it, and Tc we consider is a Curie temperature. Curie temperature is a temperature at which a substance can change its magnetization property. No, it cannot go lower than 0. It can be brought. The graph is exponential, it can be equal to 0. We'll just manage to touch the x-axis. So it's clear हुआ, diamagnetic, paramagnetic, ferromagnetic substance.
Yes, sir.
Can I erase this?
2 minutes.
One more mathematical relation you put forward. Listen carefully, I'm putting it at the top. Students, can you tell me what's the formula for relative permeability, students? What exactly is relative permeability?
Mu med upon mu 0.
Yes, it's mu for a medium upon free space. अगर मैं diamagnetic substance लेता हूँ ना students, for diamagnetic substance, do keep in mind your relative permeability, students, getting it, will be always greater than 0. For paramagnetic substance students, the relative permeability students will be greater than 1 but less than 2. So it's greater than 1 but less than 2. If in case these are the values given to you, but if I happen to go for ferromagnetic substance, the relative permeability students is much more greater than 1. Much more greater than 1. To keep in mind. This is all students simple. अगर college exams में अगर theoretical MCQs पूछते हैं, okay, there are first 12 questions which they try to put forward. अगर वहाँ पे one line answer पूछा, okay, यार MCQ पूछा, तो can ask onto this part of it. Just can I erase it now?
No, sir, I'm at temperature dependence.
Okay. And please to remember the Curie temperature for iron. The Curie temperature for iron is 770 degrees. It's 770 degrees Celsius or 1043 Kelvin. Celsius to degree Celsius to Kelvin at 273. It's 770 in Celsius. So it's a type of question they can simply ask you in this, okay, for the substances. Suppose if I happen to give you a substance, okay, a diamagnetic substance. Okay, if I try to take a diamagnetic substance and keep it into an external strong uniform magnetic field, and ये type of magnet में रहता है students, and ये diagram अलग होगा, ये diagram अलग होगा. यानी ये सोचो कि ये मेरा, please can I move ahead students? हाँ. So this question ये है कि मैंने एक diamagnetic substance लिया, एक rod लिया है, उसको मैंने धागे से बांध दिया है. I am trying to suspend it into a strong uniform magnetic field, external magnetic field. होगा क्या? क्या होगा? Will the substance will align itself with respect to the external magnetic field? यानी ये जो magnetic field है, इसकी कहाँ से जा रही है? From north to south. Will you find out the diamagnetic substance will align itself along the north south? Not at all. Diamagnetic substance के अंदर what exactly consider is the other substances in which what exactly the susceptibility is what? It's very small and negative. We consider it's in that case what happens? ये जो rod होगा ना, जैसे तुमने अंदर introduce किया, the rod automatically, कौन सा rod? Diamagnetic rod. Students, diamagnetic rod automatically will start aligning itself. The answer is no. From a region of stronger to a region of weaker. यानी तुम्हारा rod automatically perpendicular होना शुरू हो जाएगा. Perpendicular line हो जाएगा. यानी ये कौन सा region है? हेलो स्टूडेंट्स, ये कौन सा रीजन है? मुझे सर ये वीकर रीजन है. हमेशा परपेंडिकुलर वाला वीकर होगा. स्ट्रेंथ तो नॉर्थ और साउथ की तरफ है, ये तो वीक होगा. दैट मींस इट्स अलाइनिंग इटसेल्फ अलोंग द वीक रीजन वी कंसीडर. वो अगर मैंने पैरामैग्नेटिक सब्सटेंस लिया स्टूडेंट्स, अ रॉड ऑफ पैरामैग्नेटिक सब्सटेंस, इफ आई सस्पेंड इट, व्हाट हैपेंस? यानी यहाँ पे क्या हो रहा है? इट विल ट्राई टू मूव फ्रॉम स्ट्रॉन्गर टू द वीकर पार्ट. ये कहाँ पे होगा? इट विल मूव फ्रॉम वीकर, इट इज स्टिल अ मैग्नेट. ऑफ कोर्स, व्हाट एग्जैक्टली इट्स वैल्यू इज स्मॉल एंड पॉजिटिव susceptibility. तो यहाँ पे क्या होगा? It will align from weaker to stronger, but this alignment is gradual. यानी gradually वो अपने आप को align करेगा. तो अगर ये तुम्हारा external magnetic field है, agreed? So if I happen to go for this paramagnetic, the rod will align itself gradually. Gradual alignment. From where to where? From weaker to stronger region. यहाँ पे from stronger to weaker. And how is the rod going to align itself? Perpendicular. लेकिन फेरोमैग्नेटिक सब्सटेंस में कैसे होगा? जैसे तुमने फेरोमैग्नेटिक सब्सटेंस अंदर डाला नहीं, वो तुरंत अपने आप को अलाइन कर देगा due to the external magnetic field. So is it clear? So this particular alignment is very fast we consider. And it's from where to where? This is gradual alignment. This is very fast alignment. This is from weaker to stronger. ये भी कहाँ से आया? Weaker to stronger. क्या ये क्लियर हुआ स्टूडेंट्स? Students, is it clear? इसी के अलावा suppose if I happen to give you a watch glass, suppose they give you a watch glass in which they put a liquid, a diamagnetic liquid or a paramagnetic liquid, तो मुझे बताओ कैसे होगा? चलो ये मैंने आंसर दे दिया, तो मुझे बताओ अगर मैंने डायमैग्नेटिक लिक्विड लिया और फॉर एग्जांपल मैंने फॉरगेट अबाउट, ये रॉड है ही नहीं स्टूडेंट्स, अभी सोचो ये रॉड नहीं, मैंने यहाँ पे एक वेसल दिया. ओके, ये वेसल है, यहाँ पे भी वेसल है, और ये वेसल नॉर्थ और साउथ के ऊपर रेस्ट कर रहा है, और इसके अंदर मैंने लिक्विड रखा स्टूडेंट. तो मुझे बताओ यहाँ का लिक्विड कैसे अलाइन करेगा? If it tries to move in this particular external weaker field, how exactly? Either gonna rod, how exactly it is? Perpendicular. So if the field is weaker, in that case, it will start aligning in this manner. Liquid elevation में आ जाएगा. अगर वही मैंने स्ट्रेंथ बढ़ा दिया तो डिप्रेशन में चला जाएगा. यहाँ पे अगर मैंने लिया तो व्हाट एग्जैक्टली? इट्स ट्राइंग टू गो टुवर्ड्स द पोल्स. स्टूडेंट्स, सो इट विल हैव अ डिप्रेशन ओवर हियर. यहाँ पे लिक्विड ऐसा आएगा, ये लिक्विड इस तरफ आएगा, ये लिक्विड इस तरफ आएगा. सेंटर में तुम्हारा थोड़ा सा डिप्रेशन होगा. यहाँ पे क्विक shift of the liquid will take place. So that's how we consider for the liquids, but provided that the external magnetic field I consider to be slightly weak. मैं strong नहीं हूँ, मैं comparatively अगर मैंने balance किया है, weak magnetic field दिया है externally in that case, तो यहाँ पे क्या होगा? Elevation होगा rod की तरफ, जैसे perpendicular तो वैसे perpendicular line होगा. ये क्या होगा? Aligning parallel. You'll find out the liquid flowing towards the poles. यहाँ पे भी liquid flowing towards the poles, लेकिन ये gradual flow होगा, ये sudden flow होगा. But in an external weak magnetic field. ये clear हुआ students? Can I erase this part students now completely?
Except the arrangement part, sir, you can erase it.
In diamagnetic, students put example water also. Water is a diamagnetic substance. Salt is also diamagnetic. When you're drawing the diagram, please see to it that you try to keep the external field weak, considering the external magnetic field to be weak in the weaker region. Can I erase now, students? Jagannath, can I erase it now?
Yes, sir.
Okay. Now, students, now comes your electromagnetic induction. So now your entire focus will be on the electromagnetic induction and alternating current. Students. Friends, from your schools, they haven't given you any question bank or such for the entire syllabus. Yes, Jagannath, that's a new topic. Electromagnetic induction and AC. Now, students, have they given you any question bank from your schools for the test or whatever it is? Because normally colleges or certain schools, they don't throw too much of pressure onto the students in that case, so they give a question bank. कि इतने ये सारे क्वेश्चंस कर लेना, ये सारे न्यूमेरिकल्स कर लेना, हो गया. हाँ, ऐसा कुछ दिया है स्टूडेंट्स टू यू ऑल? The reason is why am I saying it, students, because after completing electromagnetic induction and AC, if in case of time permits, और अगर तुम्हारे पास हो, and if I get that particular material in my hand beforehand, then we can have one session maybe for an hour or 1.5 hours only onto the questions of that. If in case if it's provided from your schools, then only. Yeah, ऐसा नहीं कि schools ने provide किया. Okay, they haven't provided. Doesn't matter. Sample papers तो ओसवाल्स के sample papers होंगे, SL अरोरा के sample papers होंगे, previous year's board questions होंगे. Fine enough with that. So you can go through it. That is nothing to worry about it. That sample papers can be worked out. Sample paper students, at the end of your syllabus, when you're actually going for the board paper, students, when they're going for the board papers, this is what should be done in that case. 5 to 6 papers beforehand, you can solve it entirely with whomever you are comfortable in physics with, the board paper. Okay, whomever, there are so many teachers in physics with you all. तो जहाँ पे तुम comfort लगता है तुम्हें तो पूरा पेपर वहाँ पे तुम्हें solve कर देना है before your board exam. That is before the board exams. इसके लिए शायद मैंने सोचा कि शायद अगर उन्होंने कुछ क्वेश्चन बैंक दिया है, क्योंकि यहाँ पे लिमिटेशंस आ जाता है कि पहले क्वेश्चन में से शायद 10 है, इसमें से 5-7 है, इसमें से 10 है, total at an average 30-40 questions, so that can be sum up in 1.5 hours. So even you know entire thing, you know, we know the entire matter, and that's why you can go for the exams. Okay, it's not given, doesn't matter. Okay, now listen carefully, students. Electromagnetic induction, alternating current. Okay, just a few introduction to it. Okay, this I'll be completing in the next lecture. So nothing to worry because there are lots of cancellation into this also. So when you go for electromagnetic induction, students, see the word itself gives you the meaning. Electro, we consider 3 electrons. Okay, inside copper wire. Okay, 3 electrons inside the copper wire gets aligned unidirectionally. Okay, due to external varying magnetic field. 3 electrons inside the copper wire gets aligned unidirectionally due to the external varying magnetic field. But over here, no contact between magnet and copper wire. That is why the word induction is used. क्या ये समझ में आया अभी? Students, the concept of electromagnetic induction is what exactly? Students, are you getting it? Answer soon. Electromagnetic induction, that means free electrons, because I made it very clear, students. अभी देखो इसके पहले वाला चैप्टर में तो भी क्लियर हो गया, हर एक इलेक्ट्रॉन को फिजिसिस्ट ने अज्यूम किया है मैग्नेट. So free electron inside a copper wire, students, inside a copper wire, which is initially what? Random motion. Please students, ध्यान से सुनना. सोचो कि मैंने एक प्लेन एक कार्डबोर्ड लिया है. Just another 1 minute, students, एक 1 minute. ओके, ये कार्डबोर्ड लिया मैंने और उस कार्डबोर्ड के ऊपर मैंने क्या किया, मैंने कंपास नीडल रख दिया. स्टूडेंट्स, सारे कंपास नीडल रख दिया. ओके, ध्यान से सुनना. और ये सोचो कि अर्थ की मैग्नेटिक फील्ड है ही नहीं. स्टूडेंट्स, मैंने अर्थ की मैग्नेटिक फील्ड को लिया ही नहीं है. तो मुझे ये बताओ, यहाँ पे जितने भी कंपास नीडल में, तो वहाँ पे नीडल कैसे अलाइन होगी? हाउ इज द नीडल गोइंग टू बी अलाइन? तो इसे सर द नीडल विल अलाइन रैंडमली, है ना? क्यों? क्योंकि अर्थ का मैग्नेटिक फील्ड है नहीं ना. तो इसी को ऐसे ही सोचो ना, इसी को यही सोचो कि ये जो कंपास नीडल है, ये सारे फ्री इलेक्ट्रॉन्स है. ये सारे फ्री इलेक्ट्रॉन्स है किसमें? ये देखो कॉपर वायर, मैंने ये वायर बना दिया. स्टूडेंट्स, मैंने वायर बना दिया, ये मैंने वायर बना दिया. तो वायर के अंदर क्या है? ये सारे जो इलेक्ट्रॉन्स है वो रैंडम है, रैंडमली अलाइन इन दैट केस. अगर सपोज मैं इसके नजदीक मैग्नेट लेके जाता हूँ, स्टूडेंट्स, इफ इन केस इफ आई हैपन टू टेक अ मैग्नेट क्लोजर टू इट, either north closer to it or south closer to it, what is going to happen? What is going to happen? I'm not letting the magnet to touch the wire. Please, I'm not touching it. Wire, I'm not touching it. There is no physical contact between the magnet and the copper wire. What is that we call induction? What am I trying to do? So you're forcing all these compass needle to align in one direction. जो कंपास नीडल्स पहले रैंडमली थे, सारे एक डायरेक्शन में अलाइन हो जाएंगे. अगर सपोज मैं सारे कंपास नीडल्स को एक डायरेक्शन में अलाइन कराऊंगा इनडायरेक्टली करने से, when all electrons, an electron which was randomly moving, when this electron aligns itself exactly in one direction opposite to it, what happens in that case? If all electrons start aligning in one direction, what exactly that results in? That results in current. So this is what follows electromagnetic induction. Free electrons of copper wire gets aligned in unidirectionally due to an external but varying magnetic field to and fro. If I take it, okay, varying constant magnetic field होगा तो नहीं होगा, varying magnetic field होगा without any physical contact is called electromagnetic. Is this much clear, students?
Yes, sir.
Okay, next lecture will be continuing further. Okay, students.
Yes, sir.
We'll wind up the sessions. Okay, bye.
Thank you so much.